use something pretty similar. The glycosaminoglycans, that's called mucopolysaccharides, they serve the same function. We have these too. You may have heard of chondroitin sulfate, keratin. You've probably heard of that from the medical field. These are, or dermatin sulfate, these are all structural polysaccharides that all vertebrates like us make. And they're made a little bit more complex than chitin. They're repeats of disaccharides. So it's an AB, AD, AB repeat pattern. And the components are either N-acetyl glucosamine, like we just saw in chitin, or N-acetyl galactosamine, or derivatives. These are heavily derivatized in these vertebrate structures by putting negative charges on them. So here's chondroitin sulfate, one of the biggest ones in joints. So here's a glucose-looking molecule. Here's a glucosamine, N-acetyl glucosamine. But both of them, notice in the number 6 position, there's some change. Either a sulfate's been added, instead of a hydroxyl group, the sulfate with the negative charge, or in this case, it's a glucose that's been oxidized. Remember, we talked about oxidation can happen. You can take a sugar and make a sugar acid, or reduce it and make a sugar alcohol. Well, this is a sugar acid. This is glucuronic acid, where the number 6 has been oxidized to the level of carboxylic acid, which dissociates its proton and becomes negatively charged. So if you look at this structure and you imagine a polymer built out of it, it's a long string of negative charges. And that's true of all these structural carbohydrates. With either the sulfate group or the carboxylic acids, they're just very strongly anionic compounds. And again, we're just seeing the building blocks, the disaccharide building blocks, and you make each polymers.